On this slide, we talk about Cartesian product. So, given two non-empty sets A and B, Cartesian product is nothing but a tuple. So, we will talk about Cartesian product when two sets A and B both are non-empty. Now, if any one of them is empty, either A is empty or B is empty, then Cartesian product is also an empty set. So you fixed two sets A and B, both of them are non-empty. As I said before, if any of them is empty, then you just say Cartesian product is also empty set or null set. So both A and B, which are fixed to be non-empty sets. So Cartesian product is nothing but a tuple. So there is two elements like this, A comma B, where A lies in set A and B lies in set B. So let us write down some examples which makes the above thing clear. So the first is, you have set A, you fix it to 1 comma 2, and you have set B which is fixed to M, N and O. Now we want to find Cartesian product A cross B. So you take first element of A and then M from B, again fix 1 from A, N from B, 1 from A, O from B, then we will switch to 2, 2 from A, M from B, 2 from A, N from B, 2 from A, O from B. So we get a Cartesian product. So you can count the total number of elements are 6 here. So if number of elements in set A, I've written A1, it is not A1 but A. If number of elements in set A is say N1, number of elements in set B is say N2, then number of elements in the Cartesian product is N1 times N2. So for example, in the example 1, we had number of elements in A was 2, number of elements in B was 3. So number of elements in the Cartesian product is 2 times 3, which is 6, and you can count it. 1, 2, 3, 4, 5 and 6. So Cartesian product has 6 elements. Example number 2. So A consists of two colors, red and blue. And B consists of 3 numbers 1, 2 and 3. So we want to find the Cartesian product. So you first fix the element of A, red, comma 1, which is element of B, then again fixing the first element of A as red, then comma 2, then red comma 3. Yeah, second element is from set B, then blue from A, 1 from B, then blue from A and 2 from B, and then blue from A and 3 from B. Again you can count the number of elements in the Cartesian product is 6, and this agrees with the formula which we will now write. Another example. So A consists of 4 elements, A, B, C, D. B consists of 2 elements, just K and L. So number of elements in A is 4, you can see, and number of elements in B is 2. So again we just write the Cartesian product. A from A, K from B, A from A, L from B, then B from A, K from set B, then B from set A and K from set B, or B from set A and L from set B, C, K, and so on. Yeah, C, K, C, L, D, K, D, L. So as you can see, number of elements in set A is 4, number of elements in set B is 2. So number of elements in the Cartesian product is 8. Yeah, 2 times 4. So now let us count the elements. 1, 2, 3, 4, 5, 6, 7 and 8. So now say there is a set which has 2 elements, -1 and 1. Yeah, so ultimately we want to find P times P times P. This we want to find. What is this? So this we will describe. So first we will do the Cartesian product of first 2 elements, P times P. So -1, 1 times -1, 1. So first I will fix -1 from the first set. So fix -1. Then take -1 from the second set, -1 from the first set, 1 from the second set, then switch to 1 from the first set, -1 from the second set, and lastly you have 1 from the first set, 1 from the second set. So for P times P times P, you just take the above 4 elements and then adjoin -1 plus 1 to it. So we take the first element, which is -1 from P times P, adjoin -1 to it. Again take -1, 1 from above, adjoin -1 to it. Take 1, -1 from above, adjoin -1 to it. Take 1, 1 from above, adjoin -1 to it. Then again take -1 from the above P times P, adjoin 1 to it. Take -1, 1 from P times P, adjoin 1 to it. Again take 1, -1 from above, adjoin 1 to it. Again take 1, 1 from P times P or above, adjoin 1 to it. So again, we are just taking elements from P times P and just adjoining 1 or -1 to it. So what are the number of elements in P times P times P? So this will be number of elements in P times number of elements in P times number of elements in P. So this will be 2 times 2 times 2, which is 8. So example number 5 is very important. This is nothing but set of real numbers. So R times R is, you have a tuple x comma y, where x belongs to the x-axis and y belongs to the y-axis. We also write it as x is a real number and y is a real number. So we draw it like this. So we have the x-axis and the y-axis and the point x comma y in here. So now we have another example. So that was two-dimensional space in example 5. Now we will talk about three-dimensional space. So we have three axes, x, y and z. So we are talking about three-dimensional space, and we can so on talk about n-dimensional space. So x is a real number, y is a real number and z is a real number. So now let us draw the axes. So this is the z-axis, this is the y-axis, and this is the x-axis. So this is the three-dimensional space.